Hi everyone, in this video we are going to do some exercise on rotational motion. Here we have a sphere that is rolling down on an inclined plane with height of 7 meters. The question is, what is the speed of the ball when it reaches to the bottom? First of all, the condition of the motion is the ball is rolling down without slipping. That means it is rolling down having omega, and then it is moving down having velocity v. As we know before, moment of inertia of the sphere is 2/5 mr squared. And from the previous video, we know that the velocity at the bottom of an inclined plane is 2g8 over 1 added by k. Here we have k equal to 2/5. So v equal to 2g8 over 1 added by 2/5. So v here is square root of 2g8 over 7/5, or v equal to 10g8 over 7. To find velocity, we use this equation 10g8 over 7. Well, we know the variable given 10 times g, 10, and height is 7 and over 7. So we can cancel this 7, and then we have square root of 100 equal to 10 meter per second. Next question. Here, the question, a bicycle wheel with a radius of 30 cm is given an angular acceleration of 2 radian per second squared by applying a force of 5 Newton on the edge of the wheel. What is the wheel's moment of inertia? Well, as we know that here, given the variable, the radius of the wheel is 0.3 meter. Angular acceleration 2 radian per second squared, and the force 5 Newton. What is moment of inertia? As we know, torque is radius times force, and at the same time torque also moment of inertia times angular acceleration. So we combine both of them. I alpha equal to r times f. I unknown alpha to r given 0.3, and the force is 5. So I is 1.5 over 2 equal to 0.75 kilogram meter squared. Next question. The question is, a force of 15 Newton pulls a rope that is wrapped around a pulley. The radius is 30 centimeters. The pulley accelerates from rest to 30 radian per second in 3 seconds. What is the moment of inertia of the pulley? So, given the variable here, the force is 15 Newton, radius 0.3 meter, and then it is accelerate from 0 to 30 radian per second in 3 seconds. So first of all, we have to find angular acceleration by using definition. Angular acceleration equal to final angular velocity minus initial angular velocity over time. So we have 30 minus 0 over 3 equal to 10 radian per second squared. By using previous formula, we know I alpha equal to RF. I times 10 equal to 0.3 times 15. I equal to 4.5 over 10. I equal to 0.45 kilogram meter squared. Next question. The question is, an ice skater has a moment of inertia of 3 kilogram meter squared when his arms are open and 1.5 kilogram meter squared when he closes his arm. If his angular velocity is 2 revolutions per second when his arms are open, what will be his angular velocity when he closes his arm? This example of conservation of angular momentum. So initial angular momentum should be equal to final angular momentum. Angular momentum is moment of inertia times angular velocity. So apply the equation. We have here first moment of inertia I1, second moment of inertia, and first angular momentum. So angular velocity afterward is asked. I1 3 kilogram meter squared, omega 1 2 revolutions per second, and I2 1.5 times omega 2. So omega 2 is 6 over 1.5, omega 2 4 revolution per second. From this example, we know that to gain the angular velocity, you have to decrease the moment of inertia. As you can see here, moment of inertia initial is 3 decreasing into 1.5, while the angular velocity from 2 increases to 4. Next question. A body is rotating. When the angular velocity of the body doubles, its rotational kinetic energy becomes. So this example of comparison between rotational kinetic energy final to rotational kinetic energy initial. We know that rotational kinetic energy we know that rotational kinetic energy is half I omega squared for both cases. So as we know that omega 2 doubles, so we can cancel some of the variable here. Half cancel, I cancel, so we have only omega 2 omega 1 squared over omega 1 squared. 4 omega 1 squared over omega 1 squared. Cancel. So we have 4. 4 is the comparison between rotational kinetic energy final to rotational kinetic energy initial. So rotational kinetic energy final equal 4 rotational kinetic energy initial. Next, spear A at the top of a rough inclined plane roll down without slipping. Spear B slides from the top of smooth inclined plane similar to the first without rolling. The linear kinetic energy of the spear B is As you can see here, the condition of the first one, the object is rolling down without slipping. So at the beginning they have potential energy, and at the end they have rotational kinetic energy added by kinetic energy. Another one, there are potential energy and only kinetic energy. So at the first condition, potential energy is being transformed into rotational kinetic energy added by kinetic energy of A. So we know kinetic energy of A is potential energy minus rotational kinetic energy. While in the second case, potential energy is directly converted into kinetic energy. So kinetic energy of object B will be greater than of object A. This kind of problem is actually a ratio of rotational kinetic energy to its total kinetic energy. As we know, moment of inertia of sphere 2/5 mr squared, and a rotational kinetic energy compared with total kinetic energy is half I omega squared over a half I omega squared added by a half mv squared. We can cancel half actually. I itself is 2/5 mr squared. Omega itself is v over r squared. We can cancel r over, same as above, 2/5 mr squared. I'm sorry, 2/5 mv squared added by mv squared. So 2/5 mv squared over 7 over 5 mv squared. Cancel. So we have 2/7. This question, the moment of inertia of a body is I, the rotational kinetic energy of the body equals to, as we know, momentum, angular momentum is I omega, and a rotational kinetic energy is a half I omega squared. So we can do it like this. If we square both of them, we have I squared omega squared. If we divide by 2I, we have I omega squared over 2. So this case, it's the same with this one. So rotational kinetic energy can be written as L squared over 2I. L is angular momentum. Okay guys, that's all for today. I hope you enjoyed this. I hope you can study from this video. Thank you. Have a nice day. Bye bye.